So picking up where we left off, we're going to look at a math example. A number is divisible by 9. It is also divisible by 3. Well, if we read that statement again, you'll notice that we're missing the two things we need for a conditional statement, which is the words if and then. So if I rewrite this as a conditional with the words if and then, I'm going to say if a number is divisible by 9, then it is also divisible by 3. Okay, so that's my original, that's my conditional, that's what I'm going to go back to as I write my converse, inverse, and contrapositive. Now, before we even get into those, think for a second. Converse means what? Go back and look at your notes if you need to. Inverse means not. Hopefully your brain's starting to go off with some of these words. And contrapositive is our flip not. So going back to our conditional, if a number is divisible by 9, then it's also divisible by 3. Well, what are some numbers that are divisible by 9? 9, 18, 27, 36. Ask yourself, does 3 go into those numbers? Yeah, it does. And if I kept going, it would work as well. So our conditional statement is true. Okay, now converse means I'm going to flip. So instead of if a number is divisible by 9, now it should read if a number is divisible by 3. So if a number is divisible by 3, then it is also divisible by 9. So I basically just swapped the 3 and the 9. And now we have to ask ourselves, is that statement true? So what are some numbers that are divisible by 3? 3, 6, 9, 12, 15, 18. Does 9 go into all of those numbers? Well, does 9 go into 3? No. Does 9 go into 6? No. Does 9 go into 12? No. So is that statement true? Not necessarily. That's false. It really depends on the number. Okay, inverse is when you not the statement. So basically, you can go back up here, copy and paste the same thing, and then just add in the word not. So it wouldn't be if a number is divisible by 9. It should be if a number is not divisible by 9, then it is also not divisible by 3. So I'm not changing the order. It's basically that original statement, just adding in the word not. If a number is not divisible by 9, then it is also not divisible by 3. And in fact, if you want to, you can even edit some of that and say, well, it is not divisible by 3. Sounds a little bit better than it is also not divisible by 3. But that sort of stuff is just up to you. But notice I didn't change the order of anything. I just put the word not into the mix. Okay, so if a number is not divisible by 9, what are some numbers not divisible by 9? 1's not divisible by 9. 2's not divisible by 9. 3's not divisible by 9. 4's not divisible by 9. 5's not divisible by 9. 6. And then it's saying 3 doesn't go into those either. Well, that would be true. Most of the numbers that aren't divisible by 9, well, 3 can't go into them either. So that's true. Also, just a hint is don't overthink the true false. Go with your gut instinct. Don't be there like, well, what if? Just don't overthink it. Go with your gut. Okay, flip not means we're going to flip and not our original statement. So I still have the if and the then there. But I'm not going to say if the number is divisible by 3. I'm going to say if a number is not divisible by 3. Then it is also not divisible by 9. So that's asking you. So if a number is not divisible by 3, then it is not divisible by 9. Okay, go with your gut instinct. So it's saying 3 can't go into it, then 9 can't go into it. If you think it's true, you're right. Okay, so now we have to figure out biconditional or counterexample. So remember with a biconditional that the conditional and converse should both be true, but they're not, which means we can't write a biconditional. We're going to have to write a counterexample. Now, the way that a counterexample works is that it disproves a statement. So let's go back to this one that we said was false. And we said if a number is divisible by 3, then it's also divisible by 9. And we listed out some numbers: 3, 6, 9, 12, 15, 18. Okay, could go on. So ask yourself, which of those numbers are divisible by 3, but they're not divisible by 9? Why did we say that it was false? What numbers were divisible by 3, but not by 9? So that's why we said false. Well, 3 would work, 6 would work, 12 would work, 15 would work. All of those would work as counterexamples. The numbers that are divisible by 3 and not by 9. And there's a lot. So 3, 6, 12, 15. They're numbers that are divisible by 3, but not divisible by 9. That's how a counterexample works. So where most students tend to struggle, losing my voice here now, where most students tend to struggle is with the biconditional or the counterexample part. So as you're going through here, ask yourself, biconditional means that it would work forwards and backwards. Counterexample is false. So let's take a look. If two supplementary angles are adjacent, then they form a linear pair. Well, if I go forwards, that would be true. If that is the linear pair, right? Two supplementary angles that are adjacent, they form a linear pair. Now let's go backwards. If they form a linear pair, then the two supplementary angles are adjacent. Well, that's also true, which means that we can write a biconditional. And I'm going to abbreviate for a bit with the biconditional, but the easiest way to write a biconditional, in my opinion, is to take out the if and the then, and then just put IFF in the middle. It sounds grammatically correct every time. So, two supplementary angles are adjacent if and only if, that's the phrase that I always include with a biconditional, they form a linear pair. It's saying that under those conditions, it will always form a linear pair. If and only if I have those conditions, it will work. If two supplementary angles are adjacent, yeah, they form a linear pair. So let's take a look at the next one. If you live in Texas, so there's my hypothesis, you live in Texas. So if you live in Texas, then you must live in Louisville. I'm going to give you a minute to think. Is that true or is that false? If you live in Texas, then you must live in Louisville. Okay, well, hopefully you said false because you're thinking about yourself. So this would be an example where I can't have a biconditional, but I have a counter example. I need something that disproves it. Now, there is a place called Louisville, I think in Missouri or Mississippi, but that doesn't count here. The counter example would be somebody that lives in Texas but does not live in Louisville, and that's most of you. You live in Carrollton. That's a city in Texas, not in Louisville or Frisco or Dallas. But it doesn't have to be in the area. It could be Austin or Houston or San Antonio. Pretty much any city in Texas that's not in Louisville would work, and that's a counterexample. Okay, I want you to pause the video and see if you can do the next two on your own. Okay, hopefully you were able to figure these ones out on your own. The next one, if the angles add up to 90, then they're complementary. That works forwards and backwards. Complementary angles always do add up to 90, so that would be an example of a biconditional. And if you were going to write it, you could cut out the if, cut out the then, and just say angles add up to 90. If and only if, or IFF for short. This is where, if you're watching the video, you're going to know that IFF stands for if and only if, because I've said it so many times. They are complementary. I know my handwriting's not the best, but that's okay. Okay, and then for this next one, if it's a red fruit, then it's a strawberry. Hopefully you said that that was false, which means that you can provide a counterexample. Now, this is where students tend to struggle with counterexamples, is that I'll always have students go, oh yeah, like red bell peppers. Well, those are vegetables, not fruits. Or one time I had a girl go, oh yeah, like his shirt is red. Okay, well that's not a red fruit. It has to be a red fruit. Remember, a counterexample has to meet the condition, but it's not a strawberry. So what are some fruits that are red that are not strawberries? Well, cherry comes to mind, watermelon, apples, raspberries, tomatoes are technically a fruit. And with counterexamples, you don't have to list them all out. You just need one. That's all that you need, is one thing that disproves the statement. Hopefully you had some good takeaways from today with counterexamples. Don't forget to use this vocabulary chart as a little cheat sheet as you're going through and working on your practice. Good luck.